Okay, instead of using all of this space to do long division, I'm going to teach you today a shortcut that will allow you to do the division without having it take up so much space and having it take so much time. And so there is an approach that we're going to need to take here to sort of tweak this a little bit. This will be example 6.3.3. And I'm going to leave the, I've got this work here. We know what our answers are when we do our division. We know that here this doesn't divide perfectly and we have a little remainder. But what I'm going to show you is that there is a way to do this that doesn't require a ton of space. All right? What we do instead is we understand that x minus a here, we're wondering if a is a factor, x minus 4. So what we're going to do is we're going to write it like this. We're going to put our 4, what we're subtracting from x. If this was x plus 4, we'd write minus 4 over here. If this was x plus 7, we'd write negative 7 here. If this is x minus 3, we're going to write 3. X minus 4, we're going to write 4. All right, because this is the 0, or we're asking the question, is this a 0? Does this factor? We're also just going to take the coefficients from here. Now, you've got to be careful to make sure that you've got 0 degree, 1 degree, 2 degree, 3 degree, 4 degree, etc. If there's any gap in here, if there were 0 x squareds, we'd have to put a 0 for the 0 x squareds. All right, so we're going to list the coefficients: 2, negative 3, negative 18, and negative 8. Synthetic division is what we're dealing with here. We're going to call this synthetic division because we're doing division, but we're not going to do it in this long drawn-out way. This is sort of an algorithm for a quicker method. All right, we like shortcuts. Shortcuts are good when they work. All right, but the way that we do synthetic division is we start by bringing down the lead coefficient. All right, the lead coefficient, and just think about that. We know that the lead coefficient has to handle this this value of this coefficient of x. All right, so what we're going to do is bring this down. The thing that's different here is that when you get numbers in this row, you're going to be adding them, whereas before you were subtracting these expressions here. All right, we're not going to subtract like we did in long division. This time we're going to add. All right, but let's multiply first. All right, 4 times 2, 4 times this number, we have to bring that one down. 4 times 2 gives you 8. Add. Negative 3 plus 8 makes 5. Multiply. 4 times 5. 20. Add. Negative 18 and 20. 2. 4 times 2. 8. And these add up to make 0. This number here that's written last, this is your remainder. Now, what do you notice about these numbers here and the quotient that we got when we did this doing long division? Hopefully you recognize that this is our constant term, this is our coefficient of our linear term, and this is the coefficient of our quadratic term. This is actually 2x squareds, a positive 5x, and a positive 2 with a remainder of 0. So when I divide this expression by this expression, I get 2x squared plus 5x plus 2. Synthetically, this took up a lot less space. It probably took just as much time, but there's a lot less thought involved. All right? Now notice something. If we were to rewind the video and kind of go back to the beginning, you would see that each of these numbers that I'm getting here are all found on each of the lines of our long division. And each of these numbers are found when we do our multiplication. So again, 1, 3, negative 2. All right, so we see these numbers when we're doing long division, and the shortcut here is, hey, let's get rid of all those letters so that we don't have to be so confused by the algebra. We can just do some arithmetic. All right, now we're going to do the same thing here to show that x plus 1 is not a factor of x cubed plus 4x squared plus x minus 6. All right, so is that a factor? So kind of continuing our use of long division here, We're going to take x plus 1. That means that when does x plus 1 equal 0? When x is negative 1. So we're going to take the opposite of this number here. All right? 1, 4, 1, negative 6. We're going to take each of our coefficients. 1, 4, 1, negative 6. First step, bring down this lead term. Now, multiply and add. All right? So, negative 1, add those, positive 3. Negative 3, add those, negative 2. Multiply these, positive 2, add them, I got my remainder of negative 4, just like I had when I did it long division, although this was a lot less work. All right? It was the same amount of steps, but each of those steps took us a lot less brain power and a lot less space on our papers. All right? So we're able to quickly show that when I divide this expression by that expression, all right, x cubed plus 4x squared plus x minus 6 divided by x plus 1 gives us x squared plus 3x minus 2 with a remainder of negative 4. All right, a remainder of negative 4. Therefore, x plus 1 is not a factor because I have a remainder. All right, so synthetic division, a much shorter way or a user-friendly way to do polynomial division. Now, there are some other things to consider. For example, what if I said 2x plus 1? Is 2x plus 1 a factor? We should obviously know that by looking at that because I don't have a 2x cubed to begin with. But we would have to solve that. 2x plus 1 equals 0, so we'd have a negative 1/2 here as our as the number that we're going to use for this algorithm. So dividing polynomials using synthetic division can be a much easier method for you to enjoy.